Alright, so I'm assuming if you're clicking on this video that you've already done some of the basic equation solving and even intermediate equation solving, so now we're getting into some harder problems. This particular equation here, what makes this one a little bit more challenging than the others is, first you can see that I have a sine function set equal to a cosine function. So I got two different trig functions going on. Secondly, I have a double angle right here. So those two things combined make for a little bit more challenging problem. Okay, remember this though. Any equation can be solved just by looking at the graph. So what I like to do ahead of time is sketch a graph of the left side of the equation, sketch a graph of the right side of the equation into y2, and then see where these two graphs intersect. And at least that will tell me what I'm looking for an answer. So I've set this up already. Here's the left side, and then here's the right side set equal to each other. When I click on any one of these points, wherever the graph intersects, and specifically here we're talking from 0 to 2 pi. So I can see that I'm going to have four answers: pi over 4, pi over 2, 3 pi over 4, and 3 pi over 2. Okay, so back to the equation. I'm going to use a double angle identity, specifically the identity that says the sine of 2x is equal to 2 sine x cosine x. And so I'm going to substitute that into my left-hand side. Now, it's a very natural thought to want to divide both sides by cosine and divide out the cosine. You got to be careful about doing that, though. When you start dividing by a variable to get that variable to cancel, you end up canceling out some of your answers. So I'm going to encourage you not to divide by cosine of x. So we got to find another way. Again, if it were just a number, you could divide both sides by a number. But if you're dividing by a variable and that variable reduces, then you've just canceled out some of your answers. So let's set this thing equal to 0. And once we get it set equal to 0, then I'm going to factor out a cosine x. And so that leaves me with 2 sine of x minus radical 2 equals 0. And you can see then the answers don't get canceled out. I still have my cosine here, and I still have my sine right here. I can use the zero product property. Cosine of x equals 0, 2 sine of x minus radical 2 equals 0. And then we can solve this for x. Now we're going from 0 to 2 pi. I didn't say that we were going from 0 to 2 pi up there, but let's just say that we are. So we want to find all the values of x between 0 and 2 pi, not including 2 pi. Alright, so for cosine of x equals 0, we can think of that as being at pi over 2, because that's 0, 1, and at 3 pi over 2, that's 0, negative 1. So those are going to be my two answers for x here, pi over 2 and 3 pi over 2. Over on the right-hand side here, I get sine of x equals radical 2 over 2. And I can figure that out pretty easily. That's going to be at pi over 4. It's also going to be in quadrant 2. Sine is positive in quadrant 2. So that's going to be 3 pi over 4. So I should have, algebraically, I got four answers for this. Let's just go back and check. Pi over 2, 3 pi over 2, pi over 4, 3 pi over 4. When we go back to the graph, there's the pi over 2, 3 pi over 2, pi over 4, 3 pi over 4. So that's how you do those problems.